Hello, welcome to another episode in the PWA series. So in the last episode, we discussed how to make your web app installable as a PWA. In the next few episodes, we'll talk about caching and how we can give that offline capability to the PWA. So caching is actually quite prevalent. So most of the times it's used for a performance boost. So the way we get that performance boost through caching is by storing some data or resource temporarily in some location so that it could be accessed relatively quickly for any future requests. So with the web app, which is our context here, the way we'll be using caching is by storing responses to HTTP requests in the browser cache. Then any future requests could be served from the browser cache itself rather than going over the network, taking the time to hop different servers and get a response. So because cache should be available locally, we have the added benefit of offline functionality too. We can make at least certain parts of the app available depending on what resources have been cached and give a better user experience. So to put all of that into perspective, let's look at a diagram that tries to capture what's going on with the caching. So here is a diagram which tries to capture the idea of caching. So in general, we have an entity that requests certain resource, and then we have a primary storage that has those resources. So each time that entity needs that resource to perform some task, can make a direct request and get a direct response from the storage. So making the direct request for the first time makes sense, but making that same roundabout trip for any future requests can be inefficient. For that reason, we have the cache here, the temporary resource storage. So the idea is when you make the direct request for the first time, you also store that in the cache so that it is available locally and more quickly to the entity. So after the first direct request, consecutive requests would be made to the cache indirectly to get access to that resource. So the cache then would serve the cache response, and if the requested resource is not available in the cache, that would be a cache miss. So only then a request would be made to the primary storage for that resource, and once the primary storage gives back the requested resource, it is then stored in the cache, served to the entity, and the process continues. So there are a lot of other issues that are associated with managing a cache. So that is out of scope for this series because we'll be using the cache API, which handles the cache management for us internally, like cleaning up some resources to make space for the new ones, tracking which is the least recently used resource to be a candidate for removal, and so on. So that is kind of the generic idea of caching. So let's look at some examples. So like I said, caching is quite prevalent, so it's used more commonly than you might think. So here is an example of using the idea of cache in the hardware. So earlier, when we had those first computers, we had the CPU there to run your code, process instructions and data. And whenever you started a program, it was loaded from the disk into the main memory, which is the RAM. And then CPU had to make a direct request to the RAM to get access to the instruction and the data to perform an operation and create the end result of that instruction. So with respect to the chip architecture, so the main memory was relatively far away from the CPU. And if we had repetitive code, say like a for loop or a while loop, it was proving to be inefficient to make the same request again and again from the main memory. So then they came up with a strategy of implementing caching by placing it between the CPU and the main memory. So now the requests were going through the cache first, and only when there is a cache miss, a request was made to the main memory to load the required instructions or the data. So the hardware cache has instruction cache and data cache, and we have different levels in it, L1, L2, and L3. So L1 being the closest to the CPU, so that would be the fastest access. So with each level, we have decreased speeds, and depending on how frequently particular instruction is used, it is placed in different caches in order to get that boost in performance. So that is the hardware context. So let's look at software context. So you might have heard of Docker. It is a way to containerize your app. So in order to create a container, first you need an image for your app. So this image is actually built in steps, starting with a base image, which typically is a minimal OS, on top of which any dependencies are installed, like some packages. And once the dependencies are installed, then we have the command to launch your app. So all of this is done by Docker server. So that is part of the Docker ecosystem. And the base image, which is the minimal OS, that is available on Docker Hub, which is a public repo of different images. So depending on how big your app is, there can be a lot of steps in building the final image. And the Docker server uses the Docker file, which has the configuration for your app to be containerized. So if you have a big app and you make changes to the build process, like changing some dependencies and so on, the build process can take time depending on where the change happens in the build process. So to actually speed things up, Docker ecosystem uses caching as well. So it has a local image cache, which the Docker server uses to see if it has an image in the cache for the build steps that are not changed. So that part of the build process would be quicker with the cache until we hit the first change. So from then on, we will have to rebuild the images. So that is unavoidable. But using caching for the parts of the build process that are not changed, we can get that performance boost. So that is with the Docker. Next is the web app itself, which is the relevant context for this series. So the entity here would be the web app, the service worker or the web page. Whenever they need some resource, say like a CSS file or an image or something, they would have to make a direct HTTP request over the network to the internet. So as you know, internet is a network of networks. So depending on where the server is, it would have to make multiple hops, and it can be time consuming to get back the response. So after the first request, if we store it in the browser cache, then any future request would be much quicker, because you won't have to hop through different nodes on the network to get a response. So just like we discussed in the previous two examples, even here, the request would be made to the network only when there is a cache miss, meaning the resource was not accessed before and needs to be fetched from the network. The rest of the resources could be served more quickly from the cache itself and would be faster compared to the network access. So we'll be using the cache API to talk to the browser cache to store a resource, clean up a cache, and other operations. So in addition to the performance, what we get through caching in the browser is that we get the offline functionality. So because we access the network only when there is a cache miss, so depending on the resources that are available in the cache, we can make parts of the app available so that the user could get some useful work done even when there is no network access. So that is like the added bonus that we get by using caching with web apps in the browser. So I hope that gives you an idea of what caching is, what role it plays in boosting performance, and also the offline functionality with the web app. So before we actually start to incorporate caching in our web app, there are a few code changes since the first episode. So I'll just quickly go over what the changes are, and then we'll dive into the coding. Okay, so we are on the Chrome browser. So one change is we have logic to display the favorites, just like we display the products on the landing page. So it has its own title there. It has its own separate URL. And also we have some custom message when there are no favorites to display or no products to display. So to show that to you, let me go to the Visual Studio Code and let me comment out the data that we actually have in the products and the favorites data structure, which is the map actually. So let's comment this out. Comment out the favorites too. Save it, and let's go back to the Chrome browser, refresh it. So now you see you have this message when there are no favorites. So add from the home page. And if we go to the home page, we also have the custom message saying that there are no products. You'll see plus button to add. So when we click on the plus button, we have the form here to enter the data for the new product. However, this part of the app is still not functional, so it is still not connected with logic to add product to the EComm platform. So we'll get to that soon. We also have an offline page to be displayed when there is no network access. So we'll get to all of that when we start writing code. So these are few changes to the code base since the first episode. It is available on GitHub. The link to the repo is available in the description. So feel free to take a look at it. So like I mentioned before, we'll be using the cache API to actually implement the caching strategy. So let's go to Mozilla documentation so that we can take a look at the cache API. So the link to this resource is also available in the description. So the browser cache actually stores key value pairs of HTTP request and response. So that is how we actually get access to the response even when offline, because it is stored as a value matching the key, which is the request. So in order to actually store it in a cache, we have to create one first. So that is done through the open method, where we give the cache name. And once we open the cache, we can then add data, remove data through other methods. So if we scroll down a bit, so we have the add method. We give the URL, which would be part of the request, and the add method would make the request and store the request response pair in the cache. So same way we have add all, which can add multiple requests. So that is more convenient rather than having multiple lines of code with single add method there. So we'll be using add all, and then we have a put. So it is similar to add, but we give additional information there. So we give both request and response. So with the add, we just give the request and it takes care of fetching the response and adding it to the cache. So we'll have to do some cache cleanup too to manage different resources in the cache. So we'll be using the delete method then, and we'll give the key, which is the request, which is used to remove that key value pair from the cache. Then we have keys, which is a way to get access to a list of requests that are added as keys and then do some operation with them. And to actually get the response for a given request, we use match or match all. So mostly we'll be using match, where we give the request for a resource, and if it is in the cache, we get a matching response, which could be used to render elements in the web page. So without further ado, let's get to Visual Studio Code and start with the caching. Okay, back in Visual Studio Code, let's go to the service worker. So in this episode, we'll be discussing the static caching. So that is caching resources that would stay relatively unchanged over time. So that could be the styling of the app, like the color, some image, like we have the image at the top. So let's quickly go to the Chrome browser. So what I mean by like things that relatively are unchanged over time pertains to the theme of the app, like the core part of the app. So here we are on the landing page, and if we go to the favorites, the page still looks pretty much the same apart from a different message. So we have the same styling here, the same image at the top, same button, like the floating action button here, and also the shopping cart here. So all of this, you can think of it as the core part of the app that is consistent across different pages in the app. So these are like the shared resources across pages and could be categorized as a core part of the app. So apart from that, any resources specific to the landing page that are not shared with other pages would also be cached as static resources, because remember that we're trying to provide an offline experience to the users so that they can still get some useful work done without the network access. So trying to maintain that consistent look even when offline would result in a better user experience. So that is kind of the thought process behind identifying different resources to be stored in the static cache. So things will be more clear as we discuss more and add resources to the static cache. So let's go back to the Visual Studio Code. Like I said before, we actually add entries to the cache. First, we need to create a cache. So we are in the install event listener, or the callback for the install event. So this would be a good place to actually store static resources to the cache, because install is the first event. It is also the lifecycle event for the service worker. So the way to actually get access to the cache storage in the browser, use the caches word. So that actually gives access to that browser cache storage. So once we get access to that, we open a new cache. So with the open method, so that is part of the cache API. So it is a promise and it returns a reference to the created cache entry. And as an argument, we give the name of the cache as a string. So let's say static assets, because here we're only storing static resources. So because it returns a promise, we get access to the cache using the .then method, like we did in the previous episode too. So .then, we have a method here. We get access to the created cache. So once we have access to the cache, now we can add entries to that cache entry there. So for that, we'll be using the add all method. cache.addAll. So what we have as an input is an iterable. So here the iterable is an array, and what we give is the URLs to the requests, like the resources. So now we need to know which resources we can add to the cache. So let's go to index.html, which is the landing page. So the good candidates would be the material icons, the material design light package, which are shared across pages in terms of styling. Then the home.css, which is the styling for other components in the landing page. Then we have the top image. We can store a single image from this collection of images and then accordingly scale that based on the viewport size. So that is also another change that we made to the code in home.css. So if we go to home.css, so here we added a styling for the top image where the width is set to 100 viewport width. So those are the viewport units, because we're setting the width of the top image 100%. So it will always size to fit the width of the given viewport. So that I feel is a better approach compared to using images of different sizes and then adjusting the padding to center it. So back to index.html. So after that online stored top image, the other candidates would be the JavaScript. So the material min, then the app.js, product listing, new product.js. So these are all the resources that are needed by the landing page to function properly and give that seamless experience for users even when they're offline. So because we have the landing page, which is index.html, we also need to add that to the cache as a request, because without the index.html, nothing else will be loaded. So let's start with the index.html in the cache. If we go to the service worker, so what we add here would be the URLs to be accessed in the request as a string. So it would be index.html. So the / marks the root, which is the public folder. And then we just keep adding different resources as URLs. So these will be converted to request objects and added to the cache along with the response object. Let's add a / there so that we have the path right from the root. So after the CSS, let's go to the JavaScript. Try to add minimal resources to the static cache here, because overpopulating them could result in some cleanup done by the browser. So try to have only those resources that are relatively static and needed by the landing page. So any other dynamic resources like the list of products that can change will be stored in a different cache. So we'll get to that in the next episode. For now, we're only dealing with the static resources. So now let's save this, go back to the Chrome browser and see what happens when we go offline. So we're in the Chrome browser on the application tab and the service workers section. So here we have the option of simulating the offline state. So if we click on it and we refresh it, so we get the offline default page given by the browser. So even though we added resources to the cache, we were actually not accessing it in the service worker when rendering the fetch responses. So let's fix that by going back to the service worker. So here we added it in the install event handler, but in the fetch, we are still trying to make the request to the network with the fetch call there. Also, another thing is we have to use event.waitUntil so as to make the handler wait until all the resources have been added to the cache. That way, any fetch events that might occur in the app won't be failing before all the required resources are added to the cache. So here, we'll be using event.waitUntil. So we'll make the event wait until all the static resources are added to the static cache here. So event.waitUntil, we'll just copy or cut this part of the caching code and put it in wait until. So now this event handler will only return when all the required fetch calls are made for these URLs and the entries are added to the cache. Now we need to make change to the fetch event handler. So here, instead of making the network request through the fetch call here, what we need to do is we need to first make the request to the cache, and only if it is not available in the cache, then we make the request to the network. That way, we can reap the benefits of storing the resources in the cache and getting that boost in performance and also the offline functionality. So let's change that here. So in event.respond with, to actually access entries in the cache, we use the match method. So what we do is we again access the cache storage, then the match method. So here we give the requested resource. So we use event.request. So we're giving event.request because when it is stored in the cache, we store it as a request response key value pair. So even though here we're giving the direct URL, this will be again converted to a request object, and that will be stored in the cache. So for that reason, when we use the match method, we use the event.request as the input argument. So the match method returns a promise embedded with the response. So we'll again use the .then method to access the return response. So if the response is valid, we just return the response, because if it is valid, it means we have found a match for that request. So we can just serve it up from the cache. But if we couldn't find a match for that request in the cache, only then we make that fetch call to get it from the network. So we can just cut that from here, paste it in here. So what we return would be the fetch. So to make this more complete, let's handle any error that you might get from the fetch call too. So we can do that with the catch method. So we can catch an error that might be thrown by the fetch, let's say when it is offline and it cannot make a request to the network. So that would be a good place where we can add a custom offline page to show the user that he's currently offline and cannot access the network. So we have actually created a custom offline page. So let's store that as well as a static resource, because that is not something we change often. So we have that in a separate folder here, offline index.html. So let's add that to the static resources as well. So starting from the root, the public folder, we have the offline folder, and in that we have index.html. So because we would be offline, all of the CSS and JavaScript, it's kind of internal to that HTML page. So right now we are in offline index.html. So here, the CSS has been added in the style tag itself as an internal style. However, you can add it in a separate file and add it to the static cache as well. But just to kind of reduce the entries, just put it in the style tag itself. Again, then we have the shade styling here, which is also part of the static cache. So we don't have offline.css. Let's remove that. And also the rest of the resources are kind of covered, apart from the offline JPG, that is the image that is displayed for the offline page. So let's cache that as well. Same way we have an image for the index.html2 when there are no products to display. So that is available in product listing.js. So let's store that as well. So now that we have added additional resources to the static cache, namely the offline resources, we can serve that from the cache itself when the user is offline. So here we return caches.match, and the resource that we have is offline index.html. So with the match method, what it does is it looks into all the caches and it will return the response of the first hit. So for that reason, in the future, we might have to clean up some caches in case there are some duplicate entries, like old and new ones, and to make sure that only the latest version of a resource is rendered in the web page. So we'll get to that soon. For now, let's save this. Okay, it seems to be an error. Just have to remove that flower brace there. Let's save it. Now if we go to the Chrome browser and refresh it, and if we go to the cache here, So we see we have that new cache created there, static assets. So if we just click in here, you see that we have all the requests listed here, and the corresponding response is also available on the type and other information. So now let's try this out, see if we're able to provide that offline functionality. As you can see, the offline flag is already set and the new service worker is yet to be activated. So let's toggle the offline flag there. And if you remember what we discussed from the first episode, the service worker won't assume control over the web pages and intercept events until it's activated. So now we need to skip waiting to activate the new version of service worker. Let's do that. So now it's active and running. So let's refresh to allow the service worker to take effect. So we still have the assets here in the static cache. So let's go back, put it offline and refresh it. So you see, we're able to render that offline page even though some styling is missing. So if you go to the network tab, if you see here, we have all the fetch requests being intercepted by the service worker. So we have some missing requests here because we don't have the network available. So if we click on this request, it is actually part of the material icons, which we actually kind of cached in the static cache. If we go there and the preview, what we see here is the font, the actual font file itself. It has been fetched from a different URL, as you can see here, the WOFF2 format, that is the actual font format. So we haven't cached that in the static cache. So that is why you're seeing the missing fonts here for the material icons. So the Wi-Fi here, it should be actually an icon. However, if we click on the sidebar, so even here, we're missing the styling here. So if we click on home, you're not able to render that landing page too. That's because even the local host couldn't be loaded. Even though we have cached index.html here, the actual request for the landing page, which is just the /. So if we just have the / here, that is the equivalent of the landing page, and if we hit enter, so it's not able to load that page because that's actually a separate request. So for that reason, we have to include that as well as a resource to be added in the static cache within our service worker, apart from the / index.html. So I just wanted to show you that differentiation, that even though we give it a string, that in turn is actually converted to a request object. So the / itself would be a separate request compared to the string which has that / and anything after that. So let's fix that by going to the service worker and including that / here. So we have to return. So let's save it. Now let's go back to the application tab, service workers, toggle the offline. So refresh it. Now we have the page here. And if you go to the static cache, now we have the request for the / there. So you see when I hover, you have that localhost 8080 and the /. That is the actual URL in the request. And along with that, you have the rest of the resources. So now let's activate the service worker again because we made a change to the service worker. So skip waiting is one way to do it. And another way is just open a new tab, close the old one, go back to localhost again and bring up the dev tools. So now you see the service worker is activated. So this is another way to activate a service worker. So we'll try to use different ways to activate a service worker throughout this series so that you get familiar with the available options. Okay, so let's put it offline and now let's refresh it. So now you see you have that image and the content rendered here. However, some resources are missing like the styling and all. So if you go to the network tab there, so that's because it needs the product.css and that is missing. Also the top image that is missing. So let's add that. So even though we don't have the styling and the full page available, we have some functionality still there, like navigating to a different page. And we get the appropriate offline page if the resource is not available. So we'll fix this with the dynamic caching in the next episode, where we actually store the resources in a dynamic cache for the page requests that we make for resources that are not available in the static cache. So for now, let's add a couple of more resources to the static cache, like the CSS for the new product and the image for the top section. Let's go back to Visual Studio Code. Here, let's add the CSS along with the home.css. And also the image. Test this again. So we come back to the application tab, get it online, and refresh it. So you'll have to activate the service worker again. Keep waiting. If we go to the cache here, so in case you want the cache refreshed, you can just right click and do refresh caches. And if we go here, we have the new product.css there and also the image here. So now when we go offline, it should be a better looking page. So let's test it out. Again, offline, refresh. So with the top image there, it looks relatively better, but still we're missing the styling there. But like I said, we'll fix that with dynamic caching in the next episode. So hope you found that helpful in getting a taste for the caching, how it can be used to store response objects in the browser, cache and render them even when offline to have a decent looking app with some functionality. So we're not done fully with caching yet. So we'll be addressing the missing styles and other resources through dynamic caching in the next episode, and also cache management through cache versioning. So if you found this video helpful and like this kind of content, consider liking this video and subscribing to the channel, because there is more content coming along in this PWA series. Thanks for watching and have a nice day.